Good morning, students. Welcome back to online classes. Today we are going to do revision. Okay. First thing is we are going to do it in theory of equations. Right. So the first one we just learnt linear equation. So if a equation is said to be linear, then we can say that it has in the form of ax plus b is equal to 0. That is, the power of the equation should be equal to 1. Then we are calling that equation as linear equation. Supposing I have, that is, we can get only one root for that equation, right? Now quadratic equation means we know that it should have the degree is equal to 2. Okay, so that means how many roots we can get? We can get 2 roots. So if I have a cubic equation, then my equation will be in the form of power 3. Then since I have 3, that is degree as 3, then I can get 3 roots for this equation. If I'm extending it like this, then I can get a polynomial. So polynomial means it may have degree is equal to n. Okay, so that means how many roots I can get? I can get n roots if my equation's degree is nothing but n. Okay, so this is the thing we just learned in theory of equations. And we just take a cubic equation. How can I form a cubic equation? So square equation, you know that how to form a square equation, right? How can we write a square equation? X square minus sum of the root into x plus product equal to 0. Is that clear? Can you remember this? So in lower classes you just studied this. If I need to make a quadratic equation, I need the sum of the roots and product of the roots. Then x square minus sum of the root into x plus product of the root equal to 0. As like we are going to form a cubic equation. So if I am forming a cubic equation, I will get 3 roots. Therefore, first one is sum of the root. So, I am adding all the 3 roots. Okay, then what is the next one? Product of the root. So, here I am having only 2 roots. Therefore, it will be product is alpha beta. But here I am having 3 roots. Therefore, I have to take a product of 2 values. So, that means alpha beta, beta gamma, alpha gamma. I am taking the sum of all the possible 2 products. Okay, so now the next one is I am going to take the product of all the 3 roots. So then this will be the general equation of cubic equation if we know the roots alpha, beta, gamma. Okay, or else if I need to find out the roots also, I can apply this concept. Then if the equation is given to me, then I can identify these things from the given equation. Okay. Now, let me see the example x cube plus 2x square plus 3x plus 4 equal to 0. So, I can compare these things, right? So, this one represents always sum of the roots. Therefore, from this I can take, that is, form a cubic equation using minus alpha, minus beta, minus gamma. So, 3 roots are given to us. We have to form the equation, but this is the given equation. So, from this I can find out alpha, beta, gamma, beta, gamma, alpha, gamma, all those things. So, if I am finding that, then this is equal to minus 2. You just take the sign over here. Minus, that is plus, minus, plus, minus. Okay, so since we have negative over here, I am taking the value as minus 2. Okay, so now we are going to take the next one. So what is the next one? Alpha beta plus beta gamma plus alpha gamma. That is plus only, therefore we can take it as 3. And then the next one is I am having minus, therefore alpha beta gamma is equal to minus 4. These are all the things I am identifying from the given equation. But what we need to do, we have to form a cubic equation using these roots. So that means what I need the same thing. I have to add all the roots and I have to take a product of 2 roots and find the summation and a product of all the 3 roots. So all these things I have to do using these 3 roots. Okay. So first we are going to find out sum of the roots. So from this I can take minus outside, therefore alpha plus beta plus gamma. What is the value of that? We just find out that is equal to minus 2. So I am going to substitute that here, then I will get the answer equal to 2. What is the next one? I have to multiply 2 roots, then I have to take a summation. Therefore, If I'm multiplying it, then I can take, that is all these negatives becomes positive now. So I will get alpha beta plus beta gamma plus alpha gamma. What is this? Just now we got it. That value is nothing but 3. So I'm just substituting that equal to 3. Okay. Next one is I have to multiply all the 3 roots. So I am multiplying all the 3 roots. Because I am having odd number of negatives, I am taking minus alpha beta gamma. But I know the value of alpha beta gamma. What is that? That is equal to minus 4. Therefore, I am substituting that over here. Then I will get plus 4. Okay. Then what could be the equation? I am going to substitute all these things here. So if I am substituting that, then I will get the equation as x cube minus 2x square plus 3x minus 4 equal to 0. So likewise, we can form a cubic equation. Is that clear, children? Okay, the next one is nature of the root. So if I am going to find out nature of the roots, then here we just take always we will take b square minus 4ac is greater than 0 means we can get unequal but real roots. Okay. So these are all called discriminant part. You know that you learnt in 10th standard. So now roots are real and unequal. Using this only we can find out. Either we can say that it is real and unequal. If it is given like this, then we can apply this condition also. Vice versa, we can do it. Suppose I have equal to 0, then my roots are real and equal. Suppose which is less than 0, then I can say that the roots are imaginary. Okay, can you remember? We just have it in the form of square root. Therefore, in the root, if you are having negative, then the roots are said to be imaginary. Okay, so now irrational and imaginary roots. Always you just remember, if you are having irrational roots, then we know the formula as minus b plus or minus root of this divided by 2a. So this portion only describe whether our roots are irrational or imaginary. Irrational means I cannot take the root from this out. Imaginary means I can take the value with the negative sign. So then I can call those roots are imaginary. So whatever decision we are attaining, whether it is irrational or imaginary, only because of this value b square minus 4ac, because it is inside the root. Okay. Therefore, what kind of irrational roots we can get? We may get it as plus or minus root 2, plus or minus root 3, plus or minus root 17. You just notice here we are having plus or minus. So, if I have irrational, if it is given that root 2, then surely there is another irrational number minus root 2 is present. You just keep that in mind. Always my irrational number comes with plus or minus. So, if one root is given, I can take the negative part of that and then find out the other root. Similarly, imaginary means I will get negative. Therefore, it is in the form of I. Okay, so I may get it as plus or minus 2i, plus or minus 4i, plus or minus root 3i. That means here irrational with imaginary. Here we are having rational with imaginary. So that means I may get minus 25. So minus 25, for 25 the root is 5 and for that negative we will take I outside. Is that clear? So these are all the kind of irrational roots and then imaginary roots. But remember, if I have one root, surely there is a negative part of the other root. If I have minus 2i will be the root, then surely 2i is also another root of the given one. So you just take this concept into your mind, right? Now, roots of a polynomial. So, I have to find out the roots of a polynomial. So, I have a polynomial means we can get a 0 polynomial or all. That is, if it satisfies the equation, then we can call it as that is 0 polynomial or a root. Okay. So, supposing I have taken p of x is equal to the given equation. So, if a number b satisfies this equation, that means if I am substituting the value of b over here, I am getting the answer equal to 0. Then what can I conclude that this one will be a 0 of a polynomial or root of the polynomial. Okay, so b is a 0 of a polynomial or we can say that this b is a root of this polynomial. Is that clear? Okay, now supposing I have a root like this a minus d, a plus d. Where can we find out like this? Yes, if my roots are in the form of arithmetic progression, then I can take it like this. Supposing I have a by r, a r, where it will be found? Yes, my roots are in the form of geometrical progression. Okay, so we are applying mostly these kind of values to solve the equations, right? So now here reciprocal equations. So reciprocal, for this I am just going to give you one example. If I have a problem like this, okay, so then see 6x power 4, again I have 1 6. 35, again I have a 35. So there is a combination of values. So if it is like that, I can take x square outside, then my equation will be reduced like this. Here there is only 1x, I have taken x square outside, so dividing by x. No x term, therefore I am dividing it by x square. So now I am just combining these values. If I am combining that, then I can calculate the values like this. So here, to solve this equation, to make it as a quadratic equation, I am going to take x plus 1 by x is equal to some y. So that means I am going to take a square on both sides, and because I need to get this value x square plus 1 by x square, therefore it will be expanded, that is 2ab, a and b gets cancelled, therefore I get only 2. So now I can bring this to the other side, I will get it as y square minus 2 is equal to this. Now what I am going to do, I am going to substitute that in the given equation. So if I am substituting that, then I will get the value like this. I can multiply it. Now I am getting a quadratic equation. So if I am solving this quadratic equation, I can get the value of y. Then I can substitute over here the value of y. Then you will get equations in the form of x. You can solve it. This is a model of reciprocal equations, right? Okay, so now we are moving to the next chapter, that is vector analysis. In vector analysis, we just learn the basic things. What are all the things we learned? If I have A and B are any two vectors, okay. So A and B are any two vectors. So then what can I find out? I can find out a dot product as well as a cross product. So if I am taking a dot product, then how can I take it? The dot product will be taken as into dot of this. That means for dot product, always you just take I with I, j with j and k with k. But always my I dot I, j dot j, k dot k value will be equal to 1. Therefore, those values will off. Therefore, we can get the answer as 3 2s are 6 minus 5 and then minus 8. So, what could be my answer? That is equal to minus 7. If I am taking a scalar product, that is A dot B, I will get an answer in the form of scalar. Okay. Supposing I am going to find out a cross product. So, if I am going to find out a cross product, then I will take the determinant. So, determinant ijk, and I am substituting all the values, corresponding ijk values. Then I have to find out as usual determinant value. Okay. So, that means here I am getting the value like this. So, if I am going to find out a cross product, then I will get equations like this. Okay. In the form of ijk. Right. Suppose A dot B equal to 0, then we can say that A and B are perpendicular to each other, or A is perpendicular or A and B are perpendicular to each other. Okay, so now we are going to learn two important theorems. Okay, so then because we learnt only theorems in 6.1, right? So cos alpha minus beta is equal to this. Once you have alpha minus beta, then we are just taking the circle. That is, the circle should be a unit circle. So in which, since alpha minus, I have a lesser value, alpha minus beta, then I have to take it only on the first quadrant. So let P and Q be the 2 points which are on the first quadrants. Okay. So I am taking the value of P that makes an angle alpha, and then I am connecting the origin from O to that is a perpendicular line and O to Q. So that one forms an value of angle beta. Okay, so now I'm just taking a perpendicular for that. Now what portion I need to get? I need to get this portion, POQ. So that means the full value is alpha. Now I am just taking that beta value also. Therefore, this is nothing but alpha minus beta. That portion only we need it. Okay, so we are taking the unit, that is radius is nothing but 1. Let P and Q be any 2 points on a unit circle. Okay, so then we can find out the values, that is angle POX is nothing but alpha and angle QOX is nothing but beta. That is the thing we just find out now. And then angle POQ is nothing but P alpha minus beta. So that is the angle we need it. Okay, so now we are taking the value of OP, that is cos alpha I plus sin alpha j, and OQ is nothing but cos beta I plus sin beta j. Is that clear? So now we are going to take a, that is using a definition. We know that cos means it is in the form of a dot product. So since it is a dot product, we just take it as cos alpha minus beta, because that is the angle we have between P and Q. Therefore, I am getting OP dot OQ is equal to this. Okay. So therefore, we are taking it by, this is the equation 1, and then we are taking the value. That means I need to find out OP dot OQ. Just I am taking a dot product of these values. Okay, I am taking a dot product of that. Then I can get the answer equal to cos alpha cos beta plus sin alpha sin beta. That is the one we need to get. So this is the second equation. If I am equating these two equations, because my left hand side are only OP dot OQ, therefore I can get the answer like this. Right?
Next one is sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Now we are taking the x-axis and the y-axis, in which I am going to draw the unit circle, and since the angle is alpha plus beta, I am going to take a point on the first, that is P is on the first quadrant and Q is on the second quadrant. So P makes an angle as alpha and Q makes an angle as beta. Now I am drawing a perpendicular lines from P and then from Q. Okay. So let P and Q be any 2 points on a unit circle. So now let angle POX is equal to what? Alpha. And angle QOX is equal to beta. And what is the thing I need to get? Angle POQ, that is nothing but alpha plus beta, because it is on the first and fourth quadrant, so we have to add it. Now I need to find out OP. So OP is nothing but cos alpha I plus sin alpha j. And OQ is nothing but cos beta I minus sin beta j. Why we are taking negative? Because Q lies on the fourth quadrant. Okay. Now, by definition, I am going to use it by definition. So, what is the definition? Sin theta is equal to modulus of A cross B divided by modulus A into modulus B. So, sin alpha plus beta is equal to OQ cross OP divided by modulus OQ cross modulus OP. So here I have taken OQ cross OP first. What is the value of modulus OP and OQ? Then they are all radius of the circle. Therefore it will be equal to 1, because we have considered unit circle. Now OQ cross OP is equal to sin alpha plus beta. So this is equation 1. Now we are going to find it by value. So OQ cross OP is equal to, I am going to take the determinant. The first row gives me ijk. Then OQ we are going to write first, then cos beta minus sin beta, and there is no k, so it will be 0. Then cos alpha, sin alpha, there is no k, that is equal to 0. So if I am using the value, then it will becomes I into sin alpha cos beta plus cos alpha sin beta into k, because the values of I will be gets that is 0, 0. Therefore, we can find out only the value of k. Now, I can cancel the value of k on both the equations. Then, I can get the result as sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. This is the thing we have to prove.
Children, do revision in exercise 1.1 to 1.5, exercise 3.1 to 3.4, exercise 5.1 and 5.5, and exercise 6.1. Thank you, children.